my gosh, where is everybody? Okay, we're at time. So we've covered everything that we're required to cover in this course. Sections 5.1 through 5.7 and section 11.3. Section 11.3 had not previously been in your homeworks. I had not added it in there. I didn't realize it wasn't added in there. So yeah, that was my problem. Okay. Five point one and 5.2 deal with composite functions, one-to-one functions, inverse functions. Sections 1, 2, and 3, I believe. Sections 4 and I think 5 deal with exponential functions, and functions sections 6 and 7, 5, 6, and 7 deal with logarithmic and exponential functions, how they interrelate, and the properties of logarithms, and solving logarithmic and exponential equations. A lot of the properties, I will not ask you directly to demonstrate the properties, but you will have to be able to use them. So yes, you will have to demonstrate the use of those properties of logarithms. Because I think section 5.7 dealt with equations. I will ask you a couple of questions about rewriting a single logarithm as the sum or difference of logarithms, expressing powers as factors. And then I'll ask you to rewrite if you have an expression that is adding and subtracting logarithms, and I'll ask you to write it as a single logarithm. You'll probably have a total of 4 problems doing those 2 things. And so that's knowing the power rule, the quotient rule, and the product rule for logarithms. And then in the process, and then solving logarithmic and exponential equations, you will need to use some of those properties to simplify one side of the equation so it's a single logarithm, so you can use another property of logarithms or use the definition of logarithms to find out what the variable is. Yeah, section 11.3 is finding determinants and using Cramer's rule. To use Cramer's rule, you have to find determinants. I will ask you to find the determinant of a 3x3 matrix. And I will ask you to use Cramer's rule to solve a system of equations involving two variables. So that would be finding the determinant of three separate 2x2 matrices, and then using Cramer's rule to determine what the solution is, or the intercept. So basically, oh yeah, I didn't mention about putting your name in chat. I just noticed. Oh yeah. See that little round shadow up there? There's a speaker hanging from the ceiling. I don't know if you can see it. No, you can't see it, but you can see its shadow. Okay. So what I'm going to do today is I'm going to start by clicking into here. And we're going to look at a couple of questions. Now we'll do this one. Just because I like the fact that they want us to do this. So using Cramer's rule, so in other words, what they want you to do here is, what do I put there? Okay. You want Cramer's rule, to find Cramer's rule, x equals d sub x divided by d, and y equals d sub y divided by d, where in this case, d is the matrix, the determinant of the matrix involving the coefficients and d sub x, we replace, and the coefficients are 1, 1, 1, and -1. The constants are the 9 and the 7. So to solve for x, the d sub x is replacing the x coefficients with the constants. So that's going to be 9, 7, 1, and -1. And d sub y is going to be, and you do the same process, but you're going to replace the coefficients of the y's with the 9 and the 7. And so we get 1, 1, 9, 7. And then you do the process of finding those determinants. So first of all, we want to write what those determinants are. And so in here goes d sub x, which is a 2 by 2 matrix because we're dealing with 2 variables and 2 unknowns. So I'm going to put a 9, a 9, a 1, a 7, and a -1 in those 4 slots in the appropriate places. So this is a 9. That's a 9. And this one is a 7. And then up here we have the 1. Negative. And now I come down here to this one. And that's what they mean by not simplifying. Is you're just going to write, the matrix into the matrix. And so down the D is the 1. 1. This is a this one. And then over here, we're going to do the same thing, except the matrix is d sub y, which is this one, the 1, 9, 1, 7. So in here, I type 1, and then down below in the denominator, it's a repeat of this one. So we have 1, 1, 1. So now we have this. So now we want to find what each of those matrices equal, what each of those determinants equal, not matrices. So if you would remember, if you have a 2 by 2 matrix, A, B, C, D, and you want to find its determinant, then you're subtracting the products of the 2 diagonals. You have the main diagonal, which is AD, so you're going to multiply A times D, and the diagonal going in the opposite direction. In mathematics, if we say opposite, usually means minus or negative. So we're going to subtract that product, CD. And so that's what we look at here. 9 times a -1 minus 7 times 1. 7 times 1. So we have a negative 9 minus 7, which is a negative 16. So x right now, I have a negative 17, a negative 16 in the numerator. And then the denominator, I have this diagonal, 1 times negative 1, 1 times negative 1, minus this diagonal, which is 1 times 1. So we have a negative 1 minus 1. Well, that's negative 2. So this is negative 16 over negative 2. And that also means that this denominator is the same thing as this one. So I got a negative 2 here for the denominator up here. That means I have a negative 2 down here. Now, simplifying here, I get a positive 8. So x is 8. Now, I don't need to find out what this denominator is again, because I already found it. So now I need to find out what this numerator is. Well, I have 1 times 7, 1 times 7 minus 1 times 9. So that's 7 minus 9, which is a negative 2. So now we have a negative 2 in the numerator, because this is negative 2 up here. Negative 2 divided by negative 2 is a positive 1. So that's what I put in here. X I got as 8, and Y I got as 1. Who wrote? So on the test, when you're asked to do this, this is the type of work I expect to see. Well, I expect you to find D and D sub X and D sub Y. D is the matrix of the coefficients. So that's 4, negative 1, 1, and 3. D sub X is replacing the 4 and the 1 with the 11 and 19. So this would be 11, 19, negative 1, and 3. And then D sub Y, I'm going to do the same thing, except I'm going to replace the negative 1 and the 3 with 11 and 19. So the 4 and the 1 don't change, but the negative 1 becomes 11, and the positive 3 becomes 19. So this determinant becomes 4 times 3 minus 1 times a negative 1. So I have 12 plus 1, right? Because this gives me a negative 1 and minus a negative is plus. So that's 13. So I know X is D sub X over D. So that's a 13 down here. And Y is D sub Y. D sub Y over D. And D is 13. So I already found 2 of my numbers for those 2 fractions, the denominator for those 2 fractions. So now I do 11 times 3, because I want to find D sub X. And that's going to be minus 19 times negative 1. This gives me 33. And this gives me a negative 19, which becomes plus 19. Was that 52? So 52 divided by 13. I did that real quick in my head and it's a 4. That was an easy one. And then the determinant of d sub y. So that gave me what x was. I simplified the fraction, you just type it in the calculator. But if you get a decimal number, then you reduce the fraction and leave it as a fraction. I don't want decimal answers on my test. Unless I specifically ask for them. So 4 times 19 minus 1 times 11. So right away, I know I'm going to subtract 11. I just need to figure out 4 times 19 is 76. Oops, 65. So 65 divided by 13, well, that's a math fact that shows up a lot in my line of work. So it resides in my head. I know that 13 times 5 is 65. So my solution here is 4 or 5. So this is going to be a 4, and this is going to be a 5. Because that's how it worked out. The only time Cramer's rule is not applicable is when the d equals 0. That happens sometimes. You can solve the equation, but you just can't use Cramer's rule. Actually, what it means is that you either have, if the d determinant is 0, then you will have 2 possible outcomes. One is you'll have no solution, and the other outcome is that you have an infinite number of solutions. And if that's the case, then you need to go through and solve for and do well, you use the augmented matrix to solve it. Okay. On the test, you will have one, maybe 2 questions dealing with this. So know how to do this with a 2x2 matrix. So you got several problems in here where you can do that. Well, main reason I'm going to solve this one is because, again, you need to find matrices. You need to find determinants. The D matrix is the matrix of the coefficients. The D sub x is the matrix of the coefficients with the x coefficients being replaced with the constants. And then your d sub y is the same thing, but now I'm going to replace 1, -1, and 2 with 3, -22, and -2. And then we need to find the d sub z because we are finding 3 unknowns. And I'm going to replace these coefficients with -3, -22, and 2. So -1 becomes -3, +1 becomes -22, and -1 becomes a -2. Because once I find those, the x equals the d sub x divided by d, the y equals the d sub y divided by d, and the z equals d sub z divided by d. Now, to find d, then I use the matrix 1, 1, -1, 4, -4, -1, sorry, 1. Please be super careful when you're writing these numbers down. So I'm finding this determinant. And you can use, to find the determinant of a 3x3 matrix, I've given you 2 ways of doing it. I tend to favor the multiplying the diagonals, and then I subtract or add depending upon which direction it's moving. Or you could do it by using minors. I'm going to show using the minors first. No, wait a second. No, we'll keep on with this one. Using minors, I always use the first row when I do this. So I'm going to be using these numbers, and I'm going to be multiplying by the determinants of their minors. And so I start with 1 times, and so I look at the 1, and I ignore the first row and I ignore the first column, and the remaining 4 numbers are the matrix I'm going to use. -1, 1, 2, -1. And I'm going to subtract this 1 times the determinant of its minor. So that means I'm going to ignore the middle row. So I'm going to ignore this column. I'm still going to ignore the top row, but I'm going to ignore the second column. And so the remaining 4 numbers, the 4, 1, and -1, 4, 1, 1, and -1, I'll use those, and then I'll find the determinant there and multiply it by the -1. And then I'm going to add. All right, so I've done these 2. So now you move on to this one. So I'm going to add -1 times the determinant, and now I'm going to ignore this row, and so the remaining 4 are so now I'm going to use these numbers. The 4, the -1, the 1, and the 2. So this becomes 1 times -1 times -1 minus 2 times 1 minus 1 times 4 times a -1 minus 1 times 1 plus a minus, so it's going to be -1 times. All right, this minus sign, change this to This negative sign changes to a minus. And then I do 4 times 2 minus 1 times a negative 1. And now I'm going to simplify what's inside each set of parentheses and basically ignore the 1 out here because the 1 times it. Okay. Negative 1 times negative 1 is 1, and 1 minus 2, we get a negative 1, and 1 times negative 1 is just negative 1. And then 4 times a negative 1 is negative 4, minus 1 gives me a negative 5, and negative 1 times negative 5 is a positive 5, so that becomes plus 5. And then 4 times 2 is 8. Negative 1 times negative 1 is a positive 2. And so this becomes 8 plus 2, which is 10, and I've still got that minus sign. So that's a minus 10. So I have 11, a negative 11, and a positive 5, which makes for a negative 6. So D is a negative 6. So each one of these fractions, I know the denominator. So that was for D sub x, D. To find D sub x, I'm going to put that matrix back. Or negative 1, negative. So I'm going to, I want to find D sub x. It's start to lose its scope. Not much better. I'm going to replace this 1, 4, and 1 with negative 3, negative 22, and negative 2. So negative 3, negative 22, and negative 2. And the rest of it remains the same. Please make sure you, when you rewrite these, you write the numbers correctly. Okay. Now, the way I typically do this is by the products of the diagonals that I add and subtract appropriately. So what I do is I copy these 2 columns down again, negative 3, 1, negative 22, negative 1, and negative 2, 2. Please make sure you write them down correctly, double check what you wrote so that the signs are the same, the signs stay correct. And so now this diagonal here is the main diagonal. I didn't need to use that color. So 3, negative 1, and negative 1. So I'm going to have it's so hard to remove. Negative 3 times negative 1 times negative 1 plus, right? And then we have the next diagonal, which is 1, 1, and negative 2. And this is why I rewrote these first two columns over here, so I didn't have to see how it wrapped back over to this. And so that's going to be plus 1 times 1 times -2 plus, I'm still adding because I haven't gone on to a different direction. And so the third diagonal going in the same direction is -1, -22, and 2. So I'm going to be multiplying a -1 times a -22 times 2. And now I'm done with that direction. Now I'm going to go in the opposite direction. Like I had said before, opposite usually means we're subtracting or negative. And so now I'm going in the other direction. So this is the diagonal in the opposite direction of the main diagonal. And so that's a -2, -1, and -1. So that's going to be -2 times -1 times -1 minus, and I correct the signs after I multiply everything out. But I keep all those signs in so I make sure and do the multiplications correctly, or so I can get the signs correct. Here I ended up with 4 negative signs, and so this is going to end up being +2, but we'll get to that in a minute. And now the next diagonal goes from 2 to 1 to 3. So that's going to be 2 times 1, 2 times 1 times -3 minus the product of the last diagonal, the third diagonal going in that direction. So we have -1, -22, and 1. So that's going to be a -1 times a -22 times 1. I'm multiplying 3 negative numbers together, so it's going to be negative. 3 times 1 times 1 is 3, so that's -3. 1 times 1 times -2 is -2. I'm adding a -2, so that's -2. -1 times -22 is a +22 times 2 gives me a +44. So I'm adding 4. As stated before, the multiply here gives me a -2. I'm subtracting a -2, so that's going to be +2. And I said earlier, using a different process but the same, I said we were going to add 2 here. Now, 2 times 1 times -3 is a -6. I'm subtracting a -6, so that's going to be +6. -1 times -22 is +22 times 1 is 22, so we're subtracting 22. I don't like the fact that we're going to get an odd number as an answer here. So did I write the numbers down correctly? Because I screwed up earlier today by writing numbers down incorrectly. 1, -1, 2, -1. Yes.
I like the keys in there.
I'll be right back. 1 second.
Absolutely.
Okay, sorry about that. Yeah, we're gonna get a negative number. I mean, an odd number. Because this is a -5 and a -22 makes for a -27. And 44 and 6 is 50 and 2 is 52. So that gives me, what? 25? All right. Did I write the numbers down correct? Yes. 22. And the question is -6 correct? Yeah. Earlier today, the D determinant I got as a -6 and I wrote it, or a -14, and I wrote it down as a +14. Which changed all my signs, the positive to negative and negative to positive. But I got all the right numbers except for their signs. But they said my D sub Z, my Z was correct, even though it had the wrong sign. So I'm boy, I want to make sure I'm doing this right. Yeah, I did it right. And so now for D sub Y, and that doesn't simplify, but I would write it this way, -25/6. And that's how I would leave the answer. It doesn't simplify beyond that. So now I'm going to put my X numbers back in here. The 1, 4, and 1. But now I'm going to replace my Y coefficients with the -3, -22, and -2. So this 1, -1, this 1, -1, and 2 gets replaced with these numbers. So that's going to be a -3, a -22, and a -2. So that's going to change my two columns over here. So this will be a 1, a 4, and a 1. And this will be -3, -22, and -2. So this over here changes. So the diagonal is in the main direction. And the diagonal is in the opposite direction of the main. So the main diagonal is 1, -22, and 1. So that's going to be 1 times -22 times -1 plus those negative signs go away. That's another mistake I made. It was not keeping track of my negative signs. So -3 times 1 times 1, -3 times 1 times 1. That just ends up being -3. And then -1 times 4 times -2, -1 times 4 times 2, so that's going to end up being a negative, a positive 8. Now we're done with the main diagonals, or the diagonals going in the main direction. Now we're going to subtract the products of the diagonals going in the opposite direction. So minus 1 times negative 22 times negative 1. So these are going to be opposites, so that's going to end up moving this. And then negative 2 times 1 times 1 minus negative 2 times 1 times 1 minus, and it's going to end up being a plus 2. Negative 1, 4, and negative 3, so that's going to be a negative 1 times 4 times a negative 3. And we get 1 times negative 22 times negative 1 is a positive 22. We get a negative 3 plus a negative 3 is minus 3. Here we get a negative 8, right? No, that 2 here is negative. It's a negative 2. And so that's going to give us a positive 8, so that's plus 8. And here I get a positive 22, but I'm subtracting, so minus 22. Here I get a negative 2, but I'm subtracting, so that's going to be a plus 2. Here I get a positive 12, so I'm subtracting 12. The 22 and the negative 22 go to 0. I'm going to double check to see about my negative 6 here. Because the calculating here may have been incorrect. And then the 8 and the 2 make for a positive 12. The negative 3 and the negative 12 make for a negative 15. So this is a negative 5. So I'm thinking the negative 6 is incorrect. I'm thinking it probably has a 5, multiple of 5. Probably it is either 5 or negative 5. So I'm going to double check my calculations up here after I'm done with, this was d sub y, not d sub x. And change my notation there. So, yeah, I got d sub x as being 25, and this is being negative 5. So all that's left is finding d sub z. So I'm going to go back and I start again with, and on your paper, you would start all over again, because I need to see all this work. Okay. But I'm not going to require you to do it 3 by 3 this way, but solve it 3 by 3. So my x and my y columns remain the same, 1, negative 1, and 2. Now my z column is going to change. Instead of being 1, negative 1, 1, and 1, negative 1, it's going to be negative 3, negative 22, and negative 2. And that means this is going to go back to what it had. The 1, negative 1, and 2. And so my products over here are going to change as I changed my matrix. So 1 times negative 1 times negative 2. 1 times negative 1 times negative 2. 6. 1 times -1 times -2 plus 1 times -22 times 1 plus -3 times 4 times 2. And then we're going to subtract the products of the diagonals going in the other direction. So we have 1 times -1 times -3. 1 times -1 times -3. And then 2 times -2 times 1 minus 2 times -2 times 1 minus -2 times 4 times -1, -2 times 4 times -1. And now I simplify each product. And that the first one, this is a 2, and this is a -22, so I'm subtracting a negative, so it's the same as subtracting a positive. And this becomes, what does that become? -24. So I'm subtracting 24 plus a -24 is subtracting 24. Here I get a +3, so I'm subtracting 3. Here I get a -44, I'm subtracting a -44, so that's +44. And this is a +8, so I'm subtracting 8. Two and 44 make for a +46. -22 and -22 and -8 make for a -30. So this is in a -30. And a -24 make for a -54. And then a -57 because of the -3. Get that right? Because that's going to give me 11. This way. That gives me a -20, and a -24 gives me a -44. -3 gives me a -47. Plus 44 gives me a -3. And okay. Yes, continue. I'm gonna take forever on this problem. I don't care. And so that's gonna, and then I'm gonna combine a -8 to that gives me a -11. So okay, -11. One times -2 times -2. 2 times 1. -3 times 4 times 2. One times -1 times 2 times 2. -2 times 4. So I wrote down all the multiplications for it. 2, that gave me a -22, so we're subtracting. That gave me a -24, so we're subtracting. Give me a +3, so we're subtracting 3. And this gave me a -44, so that becomes +44. Okay. So I'm going to type those in and see if I got it right. Because it didn't say its usual stuff about and put your answer in as an integer or a fraction, a simplified fraction. So this was the fraction 25/6. And this became the fraction 5/6, because -5/6. Oh, this one's supposed to be negative. This one's going to be positive, and this one's going to be positive. I'll go back and fix that negative sign. So now this one's going to become 11/6. If it says I'm wrong, what are your answers? The Z is correct. Huh. They're saying my Z is correct, but everything else is wrong. Well, I want to double check my D. Well, they're saying this is correct. Well, let me check my D anyway. And I'm going to do it the way I'm most comfortable with. So we have 1 times -1 times -1 plus 1 times 1 times 4. No, 1 times 1. Right? So that'll be 1, 4, 1. And 1, -1, 2. So this will be plus -1 times 4 times 2. Minus 1 times -1 times -1. That's this diagonal. And then this diagonal, which is -2 times 1 times 1, minus this last diagonal, -1 times 4 times 1. So that is a 1. That's a 1. That is -8, so we're subtracting 8. This is 1, so I'm subtracting 1. This is 2, so I'm subtracting 2. And this is -4, so I'm adding. One plus 1 is 2. So this is 2, and this is a -2. So this is a -8, a -9, plus 4 is a -5. So how could Z be correct if I got the wrong number for D? So that means X is 25 divided by -5, and -5 divided by -5. And this is supposed to be -5. 5 down here. So this will be a +1, or this will be 11/5. Unless unless my d sub z is not a -11. Let me find out if that's correct. So 1 times -1 times -2 is a +2. That gives me a -22. No, -22. That's -22. This could be a -24. -3 is correct. 4 is correct. And 2 is correct. And then this way, 1 times -3 times -3 is a +3, so it's a -3. 2 times -2 is a -44. And -4 times 1 is -44, and I'm subtracting, so that's +44. And then that gives me a +8. Is that supposed to be a -1? No, that is not a -1. That's supposed to be a +8, -8. +8. So if I put all the positives together, that gives me 54. And putting all the negatives together, -22 and 24 make for a -46. So that's going to be a -49. So I'm subtracting 49, which is 5. Right. So D, I have gotten wrong. It's supposed to be a 5 because I put in a sign that should not have been there. It's 5 over -5, which is a -1. So no, my Z is not correct. Silly people, they think I did it right.
I got the same thing. So like I'm working on question 11 on my assignment, and I did exactly the steps like you're doing, but with my numbers, and it told me the same thing, that I got Z right, but I got X and Y wrong.
Yeah. So let me see what that, yeah, that seems to be a a problem with the function, with the MyLab. It's very frustrating. My first clue should have been that I did not get a fraction for X. I mean, that I got a fraction for X. This is a negative. Yeah. So I'm getting the suspicion that on this particular problem, because I think I worked this problem earlier, is that they don't care what you get for Z. They're gonna say it's right no matter what you put there. Because I had gotten a +4, but it was supposed to be a -4 previously. And they said my +4 was correct. So you saw the mistakes I made here. One was I didn't completely erase the number. That's why I want you to rewrite it, not. Another reason I don't want you to erase is so I could see all your work. I have limited workspace here. We'll have a complete board over there I can use, but y'all won't be able to see it because the camera won't move it. So we have to deal with this. Okay. But what I will ask you to do is to find a matrix, find a determinant of a 3x3 matrix. Yes, I want to move this page. Yeah. So let's see. So this will be, I'll ask you to, I'll give you a matrix and ask you to find this determinant. And so that's just, that would be just be, I would repeat the 3, 3, the 1, -5, and the 1, 1. And then I look at these diagonals going this direction. And so that's going to be 3 times -5 times 3 plus and so now I'm going to subtract these diagonals. The 1 times -5 times -5. 1 times -5 times -5 minus the product of this diagonal, which is 1 times 2 times 3, minus the product of the third diagonal in that direction, which is 3 times 1 times 3. 3 times 1 times 3. And now I simplify the products. So this gives me a negative 45. That gives me a plus 6. That gives me a minus 5. That's a positive 25, so it's minus 25. That's 6, so it's minus 6. And that's 9 at the end, so that's minus 9. Only have one, but I have a 0 pair, the plus 6 and the minus 6, so I can forget those. And so everything else is just being added because they're all negative. And I'm going to get a negative answer here. And it's going to be a largish number. So here I have negative 50. So I have a negative 75, because I'm going to add the negative 25 to that. And then I'm going to add the negative 9 to it, which gives me a negative 84. Let's see if I did it right. Okay, what did I do wrong? Notice I did it in a hurry.
You put positive 84 instead of the negative 84 in the answer box.
Ah, thank you. You do that on the test, I usually don't take a point off for that. I will circle it and note it, but I won't take I usually don't take a point off. So these are the type I'll be asking you to do using Kramer's rules. So you're going to have to find 3 matrices, 3 determinants, and they're 2 by 2 matrices. So to find D, well, that's the determinant of the matrix of the coefficients for negative 1, 1, and 3. D sub x is going to be the determinant of this matrix, of this determinant, with the 1 and the 4 being replaced with the 11 and 19. We have 11 and 19 here, and this is going to be negative 1 and 3. And then the D sub y will be the x coefficients remain, but now the negative 1 and 3 gets replaced with the 11 and 19. Because now I know x is going to equal the D sub x divided by D. And the y is going to be the D sub y divided by D. So I find out what D is first. This diagonal, 4 times 3, minus this diagonal product, 1 times a negative 1. So that's going to be 12 plus 1, which is 13. Did we do this one already? It sounds awfully familiar to me. So I know the denominator of both those fractions. So now this one, the d sub x, I'm going to multiply the 11 times the 3, and I'm going to subtract the 19 times the negative 1. 19 times negative 1. 11 times 3 is 33. Negative 1 times 19 is negative 19, but I'm subtracting, so that becomes plus 19. And so that's going to be what? 52. So 52 over 13 simplifies. That's actually 4. I've done this one before. And then we do the 4 times the 19. And we're going to subtract the 1 times 11. 4 times 19 is 76, I believe. 76, and we're going to subtract 11, so that's 65. Which is 5. This is one of the math facts that reside in my head. 13 times 5 is 65. This one does not, but it's easy for me to solve. So this is a 4, and this is a 5. I know this one is correct because I solved this one. So what do I expect on the test? I expect to see all this work. I expect to see these two fractions and then what they equal. And I will make sure that because of how I create my equations here, these will be, unless there's a typo when I type it into the test, they'll be integer numbers. So they'll divide nicely. Yeah, I know I did. I do that. Okay, that's not let me do it. So next time we meet, I expect you to have gone through the homeworks and come to class with questions, concerns, problems you want me to look at and work through. Part of that's probably the best review for the test is this homework. And if you're getting different answers than they are, and you make sure you're setting it up correctly and you're working it correctly, except they're saying your answers are wrong, and you can't determine how they're wrong by the answers they say are correct, well, that's something to bring up in class. Because you may be correct. Because sometimes, like on that one particular problem, they said my Z was correct, even though my Z was incorrect. any questions? All right, about the supplemental work, if you were not able to get it in on time, please let me know. If you emailed me a copy of it, please let me know. And well, I think I've already addressed the people who emailed me a copy. And I will allow you to post it. And it will get a late label on it. And I don't know if the duck points yet or not. Probably not, because I want to work. And so, depending upon which supplemental exam 2 you got, it may be open already if you have not sent it in already. Any more questions? Any thoughts? I'm basically done with y'all for today. Chapter 5. Chapter 5 and then the section 11.3. I didn't work any of these problems out of chapter 5. Yeah. If you have any questions about any of the homework problems or any of the homework sections, come with those questions.
I got a question, sir. Do we make those?
Say again?
If we made those that you didn't explain, or the ones that you say before?
Yes, sections 5.1 through 5.7 and 11.3 is what the test is going to cover.
Oh, okay.
So you get in there and you do those homeworks. That helps. That's where you start learning.
Can you repeat me the works that it's 5.5?
5.5.
Yeah, sir.
What about it?
No. Which ones in a specific? Can you repeat me the ones that we need to work on it for the test?
Can you see what's being shown on the on my screen up here?
Yeah, actually, I got you pinned, but all of them?
All of them.
Oh, okay.
That's
Okay.
what
I get confused. I just mean that just some of them, but yeah, it's I already got the page actually on my computer, so there's no problem.
Okay. So yeah, sections 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, and 5.7, as well as 11.3. How many sections is that? That's 8 sections. And some of them will be covered pretty heavily and some of them pretty lightly.
Bye, sir. Have a good Thanksgiving.
You too.
We are meeting on Wednesday, right?
Yes, we are.